for you, and then be off and rolling. So solving exponential equations, but then working with some exponential applications as well. Okay, so when I say solving an exponential equation, 3 raised to the negative x equals 3 to the 4th. Okay, how do I solve that? Or what can I do? Is it saying 3 raised to something, it's a negative something, has to be the same as 3 to the 4th? Well, yeah, this is nice because they're the same base. So to make these two equal, my exponents have to be equal to each other. Now I don't have to worry about the base. So all I'm saying is negative x has to equal 4. All right, if negative x is going to equal 4, really this is a negative 1. So I could divide each side by negative 1. And so I could say x would have to be a negative 4. All right, and then don't get tripped up by the signs. X is negative 4, because if you put negative 4 in for x, you would do a negative of negative 4. That's why it's positive. All right, now the second one. 2 raised to the x power equals 8. So like in the first one, we wanted that same base, because once we get them to be the same base, then all we have to do is make the exponents equal to each other. 2 cubed is the same thing as 8. So this is saying 2 to the x is going to be equal to 2 cubed. So therefore you could say, well, x would have to be 3, not 4. All right, with this idea of getting them to be the same base, then you can essentially ignore what the base is once it's the same, and you're just trying to make it equal to each other. Okay, all right, so let's expand on this a little bit. So if we want to know what 1/3 raised to is equal to 81. Okay, well, we're not going to try to make 81 have a base of 1/3. Is this the same thing as 3 to the negative 1st raised to the x power? Could I do that? Is that equivalent? Taylor, what do you say? (50-50) shot, yes or no? Yes, good job, good job. Okay, because this is really 3 to the 1st, and so I could bring it up, and it's really 1 times 3 to the negative 1st, but you wouldn't have to write the 1. All right, is this the same as saying 3 raised to the negative x equals 81? Can I do that? Can do that, okay? Because you multiply exponents if they're separated by a parenthesis. So now I have 3 to the negative x equals 81. So I can see I have a base of 3, 81. So can I do 3 raised to some exponents that'll be the same as 81? And I don't expect you to be like up on all of these, but if you did the cube roots of this, or I'm sorry, we'd even do more. So 3, so you're trying to say, okay, 3 times 3 times how many will it take to get 81? I could do that. That's 3 to the 4th. So now I have 3 to the negative x equals 3 to the 4th. So just like our warm-up, I don't have to worry about the base anymore. I'm just trying to make negative x be the same as 4. So then x would equal a negative 4. So manipulating your fractions, you can move those around, move stuff from the denominator up to the numerator. But the big thing is we want to get it to be the same base. Okay, let's look at another one. 2 raised to the x plus 4 equals 8 to the x minus 6. Same thing here. We want to get this to be the same base. So I know 2x plus 4, if I want to write this with a base of 2, this is really 2 cubed. And then this is raised to the x minus 6. So my new exponent with a base of 2 is really 3x minus 18. So that 3 applies to each term. You can think of it, it's the distributive property, 3 times x, but then 3 times negative 6. Now I've found my same base, so that's easy enough. I just need to make x plus 4 equal 3x minus 18. If I were to add 18, subtract x, that's going to put me at 22 equals 2x. So therefore 11 would be x. All right, so we can see this common theme of finding that same base. What about now where I have a variable that's raised to the 4/3 power? All right, there's a couple ways that we could do this. How could I undo the 4/3 power on the left? What do you think, Mason? Not even that. How could I put a new rational exponent outside of my parenthesis that will, in a sense, undo each other? What if I raise it to the 3/4 power? So x raised to the 4/3 raised to the 3/4, we multiply those, we end up with 12 over 12, which is 1. So now I only have x to the first, but because I introduced that 3/4 on that side, I have to do it on this side as well. Okay, now this right here, because of this even denominator, we need to bring in the plus minus. Okay, so really this is x equals plus minus root, or plus minus 81 raised to the 3/4. So therefore in this one, we could say x, oops, I don't like that color. X then would equal plus minus 27. You can put that in your calculator because this is the 4th root of 81 cubed. And again, this 4th root, that's why there's that plus minus going on. Any even index is that plus minus. That's another check. Make sure you get that plus minus going on. All right, so x equals plus minus 27 for this one. All right, so these are solving when you have an unknown exponent, but also solving if you have a rational exponent and need to solve for the base. Now let's get into some applications, and you've seen this before, but we're going to do some practice problems with compound interest. So this is an exponential function. It has an exponent, and you can have an unknown in the exponent, or the exponent changes. So for compound interest, A equals P times 1 plus R over N, NT. So these ones we're talking about money. What does this P represent? The principal. What is principal? It's your starting amount. So whatever the problem be set up that you have $500 and you're investing it, blah, blah, blah. So this principal is just your starting amount. This A then is your final amount after compounding the interest. What does this R represent? The rate, and it's the rate as a decimal. Right? So if they tell you 5%, you're actually going to put in here for your R 0.05. So always take your percentages and write them as decimals. What about this N? So that N represents. Anybody remember what that N is? So this is the number of times compounded annually. So if they said, if it's only compounded annually, it would be 1. But if it was, say, compounded monthly, and they'll say that in the setup to the problem, compounded monthly, N would be 12. Compounded daily would be 365. So that N is that number of times compounded. And then T is your time in years. So make sure it's in years. If they say it's compounded $500 at 2%, compounded monthly, how much we have in 6 months, your T would actually be 0.5. Okay, so that T is in years. So if they give it to you as a month or something, you have to convert it to what it is actually in years. So that's compound interest. We can also do continuously compounded interest, which is A equals P times E raised to, raised to the R times T. And E is 2.7. Like E is that number on your calculator. So E is not a variable. E is like pi. Pi is a number. They just use the symbol pi. E is a number. They just use the symbol E. And then R, again, is your rate as a decimal. T is in years. P is your principal amount. Okay. Let's actually use this formula now. Taylor must pay a lump sum of $6,000 in 5 years. What amount deposited today, that present value, at 3.1% compounded annually will grow to $6,000 in 5 years? So in that blue equation on the top, what are we trying to figure out? What are we trying to find? P. We're trying to figure out what P is. Okay, so we can set this up and we could say, well, we want to have $6,000 as our final amount. P, we don't know. That's what we're trying to find. 1 plus our rate, so this would be 0.031. Compounded annually, and so that's just once per year, raised to the N again, which is 1 times 5. All right, so this is really P times 1 plus 0.01 or 0.031 would just be 1.031 raised to the 5th power. This is still equal to 6,000. So if we divide this away, 1.031 raised to the 5th power only in the denominator will equal P. That's approximately $5,150.60. Okay, so we have $5,100. You set it aside, don't touch it for 5 years, and you're getting 3.1%. You'll have $6,000 just from letting it set. Okay. Same setup. If she already has $5,000 available to deposit now, what annual interest rate is needed to get to $6,000 in 5 years? Okay, so this one still we're trying to get out to be $6,000, but now we have $5,000 to begin with. We're going to have 1 plus r over n, but our n is 1, so I'm just going to say 1 plus r, because we're still doing it annually, raised to the 5th power. So now in this one, we're trying to find that rate. All right, well, we can divide 6,000 divided by 5,000. I'm just going to simplify that right away. That's a 6/5 is 1 plus r raised to the 5th power. Now, where do I go from here? How can I, because I want to undo that 5th power, okay? I can't do anything with that 5th power there hanging on. What could I do as a next step? Okay, so Mason, you made a radical symbol. Okay, so we could do the 5th root, which is the same thing as raising it to the 1/5 power, but I have to raise this to the 1/5 power as well, or the 5th root. Okay, either way. So I have 6/5 raised to the 1/5 power now equals just 1 plus r. I've undone that 5th power as my exponent on the right. Trying to solve for r, so if I subtract 1 from each side, so 6/5 raised to the 1/5 power, subtract 1 will equal r. And when I do this, r is approximately 0.0371. Is that it? Would that be the final answer? We want it to be as a percentage, so we're going to move this over to, so it's 3.71%. So make sure you understand in the context of the problem what your answer actually represents. If you're solving for r, it'll give you r as a decimal, but you want it as a percentage. One more. Okay, this one will go quick. Suppose Olivia found $1,000 and wisely invested it at 4%, compounded quarterly for 10 years. How much would she have? So it'd be our amount A we're trying to figure out. 1,001 plus 0.04. What's going to be my N value on this one? 4. Okay, compounded quarterly, 4 times per year. So 4 is my denominator on this. And then 10 times 4 up here in the top. And we end up with 1488.86. Okay, so that $1,000, set it aside 10 years later, getting $488 without even having to do anything. continuously compounded, that would be that PERT formula. So 1000e raised to the 10 times 0.04 ends up being 1491.82. So again, that E is a button on your calculator. Hit the E button, it'll automatically let you put it up into the exponents. 10 times 0.04, and that will give you the answer. Okay, continuously compounded doesn't happen too often unless you get into credit card debt, and credit card companies will hit you with continuously compounded. I've yet to see an option where I can invest money and somebody will pay me continuously compounded interest. Okay, not to say it's not out there, but they like to go the other way. All right, so 4.2, due Friday by class time.